Hello, welcome back. In this session, we will understand how do we apply the advanced analytics to cognitive computing. This is a very interesting area. Advanced analytics is all about using the techniques, methods, and algorithms towards identifying patterns in the large, complex, high velocity dataset. And they may also have varying degrees of structure. And it can include the statistical models, the predictive analytics, machine learning, neural networks, text analytics, and other advanced data mining techniques also. Our aim is to identify patterns from the large data, which can be very complex. And when you use advanced analytics, you'll be able to get it easier. And the techniques could include machine learning, predictive modeling, neural networks, text analytics, everything can be in that picture. Now, some of the specific statistical techniques used in the advanced analytics can also include tree analysis, linear and logistic regression analysis, social network analysis, and also time series analysis. So, this is very important points to remember. And the role of analytics in an organization is not deniable. It has been growing faster than ever, and for the past 30 years, this has been in the picture. Organizations are significantly relying on the data analytics to understand how do they perform. Predictive analytics, machine learning, more are used by the organizations to understand where do they lack, where do they do well, how do they improve. Companies have been successfully using analytics to understand both where they have been and how they can learn from the past to anticipate the future. The point is very important here. The companies are not only looking forward to understand what has happened, but they also want to understand how do we anticipate the future with what has happened in the past. They can describe how various actions and events will impact the outcomes. Although the knowledge from this analysis can be used to make predictions, typically, most of the times, these predictions are made through a lens of preconceived expectations. That's a problem. Data scientists and business analysts have been constrained to make predictions based on analytical models that are obviously based on historical data. This is a very strong constraint. But however, there are unknown factors that can also have an impact on the future outcomes. You may have to think about that as well. So companies now need a very strong way to build predictive models that can react and change when there are changes in the business environment. This is a very important aspect to understand. Not just the historical data, not just the past, there are other things that can as well influence the future, and that's what we need to take care also is mentioned here. Now there are four kinds of analytics that you can get into picture with. The first one is descriptive, second is predictive, third is prescriptive, and fourth is machine learning and cognitive computing. Descriptive analytics is all about understanding what happens when using analytic techniques on the historical and current data. Please make it very clear in your understanding. It is used to understand what happens when using analytic techniques on historical and current data. For an instance, which product styles are selling better than this quarter as compared to the last quarter? Which regions are expecting highest or the lowest growth? These are all the kinds of questions that can be connected to the descriptive analytics. Coming to the predictive analytics, it's very important to understand what it is. Predictive analytics is all about understanding what might happen when using statistical predictive modeling capabilities, which can include the data mining, machine learning techniques. Predictive models use the historical and the current real-time data to predict future outcomes. The models will always look for trends, clusters of behaviors, and events. Models also identify the outliers. This is a very important aspect to understand. They also identify outliers. Some examples can be very easy to understand here. What are the predictions for the quarter's sales by product and region? How does this impact the raw material purchases, inventory management, and human resource management? See the kind of questions that are differing from the descriptive analytics approach and the predictive analytics approach. This is a very important aspect to understand how exactly the analytics type is getting different and what kind of questions can be answered through following these approaches. Then comes the prescriptive analytics. Prescriptive analytics is used to create a framework for making a decision about what to do or what not to do in the future. I repeat, it is used to make a framework which will help you in understanding what to do and what not to do. The predictive element should be addressed in prescriptive analytics to help identify the consequences of your actions, the relative consequences of your actions. Most importantly, this uses an iterative process so that the model can learn from the relationship between actions and outcomes. Can we have an example? Yes. What is the best mix of product for each region? How will the customers in each region react to advertising campaigns and offers that we are giving? What kind of offer should be made to each customer to build increased customer base? These are all the kinds of questions. Now the first one was descriptive, the second one was predictive, and the third one is prescriptive. And finally comes the machine learning and cognitive computing. The collaboration between the humans and machines are becoming very trendy. It's being more and more better, and it's increasing. So we need to think about this aspect of collaborating between the humans and the machines to solve complex problems. So using this machine learning and cognitive computing, one should try to improve the efficiencies and effectiveness of the solution. And most importantly, we should be able to reduce the errors in predicting the outcome. And some examples would be very handy here. How secure is the city environment? Are there any alerts from the vast amount of information streaming from the monitoring devices, which include video, audio, and other sensing devices? Which combination of drugs will provide the best outcome for the cancer patient and based on specific characteristics of the tumor and genetic sequencing? So here the collaboration between human and computers, collaboration between human and machines have been highly encouraged, and most importantly, they work together and they tend to solve problems in a much better way, and then the prediction also is getting much better. So these are the maturity levels. It started with descriptive, went on to predictive, went on then to prescriptive, then machine learning and cognitive computing. Now we have drawn a picture very clearly here in the right hand side, which will let you know how exactly things look like. The analytics is in the left hand side, artificial intelligence is in the right hand side. Let's start with descriptive, predictive, prescriptive, and in the machine learning side, knowledge representation, natural language processing, machine learning, and finally we converge to cognitive computing. There is a convergence which happens here across the analytics and artificial intelligence, and it has been nicely represented here in this picture. There is a major push for this convergence in the market, and we are all working towards it. Multiple applications that you are working on today definitely requires extraordinary planning and operational changes at a fast rate for the business to remain competitive and to sustain. You cannot wait for 24 hours or longer to get a result of a model running. You have to be really fast. Also, the data sources are becoming much more complex and much more diverse. So analytic models need to work in conjunction with artificial intelligence to ensure that we are getting right results, and most importantly we will also have to think about including structured, unstructured and streaming data to improve predictive capabilities. So this is a very important aspect of it which we need to understand, that the technology has to converge. Analytics and artificial intelligence must converge together to get you cognitive computing. Increasingly, advanced analytics is deployed in high-risk situations. Take an example which can be patient health management or mission performance management or threat and theft management. These are all the areas advanced analytics is deployed so that we get nice predictions done and the results are meeting our expectations. In these use cases, the ability to predict outcomes with a very high degree of accuracy can even save lives, can even save us from major crises, can avoid damages. Also, advanced analytics and machine learning are used in situations in which the large volume and the fast speed of data that must be processed demands automation to provide competitive advantage. This is a very important way of thinking. We need to go ahead with automation, and that's done in order to retain ourselves, in order to sustain ourselves in the competitive environment. So whenever you have a high risk environment, you will go ahead with advanced analytics so that you can avoid any damages, any risk well in advance through appropriate predictions. Now, what are the key capabilities in advanced analytics? You can't develop a cognitive system without using combination of predictive analytics, text analytics, or machine learning. Yes, you cannot do that. It is dependent on all of these, in fact, to develop a system to be cognitive in nature. It is through the application of the components of very advanced analytics that the data scientists are able to identify and they are able to understand the meaning of patterns, and they are able to detect anomalies in the large amount of data, which in turn are structured, unstructured, and at times they are streaming data also. These patterns are used to develop models and algorithms that help determine the right action. The course of action can be clearly determined. You can arrive at a meaningful insight when you get patterns properly understood. The analytics process clearly helps you to understand the relationship that exists among the data elements and the context of the data, which will drive you to meaningful conclusion. Machine learning is applied to improve accuracy of the models, and it enables you to get better predictions also. It is very essential for us to take up advanced analytics, particularly when you are handling the big data. Advanced analytics gets in picture naturally. You are able to handle the data which are streaming data, structured data, unstructured data, and you must have to go with advanced analytics for you to get the analytics done nicely, correctly, and also efficiently. In addition to just machine learning, advanced analytics capabilities including predictive analytics, text analytics, image analytics, speech analytics are also used. So you may have to know all this when you are going to that kind of systems which are getting built. So please understand, these are the key capabilities in advanced analytics. Well, using advanced analytics to create value is the next thing that you need to understand. What is the goal? Ultimately, the aim is towards deploying advanced analytics process and cognitive computing to improve the decision making. The companies are using analytics to differentiate from the competition by doing a better job. I want to do better than my competitor so that my customer gets benefited. You need to get clear inputs for your customers so that they can understand that you are better than your competitor, and they will choose you over the competitor as well. The government agencies use analytics to differentiate their sites by making them safer, more responsive for the citizens, and ecologically more sound. Healthcare organizations on the other sides are using the analytics to improve the physician training, eliminate unnecessary hospitalization, and improve overall quality of the healthcare that they are giving. Building the analytics models and cognitive computing environments that support these improvement in the decision making requires real large volume of data, more accurate data, refined data, all these are required. And also the ability to manage and interpret data from all the input streams at a faster rate is also required. We are adding value to multiple domains, but we have some requirements which I mentioned. The ability to make faster and more execution oriented decisions clearly depend on reducing the degree of difficulty of interpreting the right data from all input streams. You have to manage the volume and complexity. The data, more bigger it becomes, and most importantly more complex it becomes, it's very tough to manage, but we have no other go. With the advanced analytics techniques, we have to manage it. And you need to also sample high velocity data in a meaningful way. Raw data, when you capture it by systems and the sensors, has a potential value, but it has to be processed and analyzed to build proper business value. I'm taking a lot of sensor data, but I need to definitely make it usable in such a way that it offers me insights which can generate business value for me. More to come, and we will discuss that in the next session. Thank you.